In this video, we'll be looking at a question on dimensional analysis and how to use it to determine alpha, beta, and gamma, which are exponents to the density of air, the velocity of the moving car, and its cross-sectional area. Now, the cross-sectional area is that surface of the moving car that interacts with the air. And as it moves, it experiences forces of opposition due to the air resistance. Generally, objects in fluids experiences drag forces, which opposes its motion. The greater the fluid influence, the greater the forces of opposition on the object. In this question, the forces of opposition to motion on the moving car is given by this formula. Now, to determine alpha, beta, and gamma, all the quantities provided have to be converted into their respective dimensions in their MLT format. And so the density of the air would have to be converted into its dimension in its LMT format. The velocity of the moving car would have to be converted, and the cross-sectional area of the moving car would also have to be converted into its dimensions in their MLT format. And so would the force experienced by the moving car would also have to be converted into their MLT format. So what is the dimensions for density? By definition, density is mass over volume. The dimensions of mass is dimensions of volume So when we apply the properties of indices, the dimensions of density now would be the cross-sectional area has the dimensions by definition. Velocity is displacement over time. The dimensions of displacement is and that of time so when we apply the properties of indices, the dimensions is given as this. Now, according to Newton's second law of motion, force is equal to rate of change of momentum, the dimensions of mass, dimensions of velocity is given here, and the dimensions of time. We're going to have the dimensions of force as so we're going to have the dimensions of force as this. Now we're going to plug these dimensions into the formula given. Dimensionless constants are not recognized or are not considered in dimensional analysis. So we're going to plug in only the dimensions of the quantities that have one. So we're going to plug in the dimensions for the air density, the velocity of the moving car, the cross-sectional area, and the force that the moving car experiences. So we have the dimensions of force is given as density let us not forget the exponent, velocity, the exponent, area, the exponent. Now, let's go ahead with the solution. Now, the exponent as we have them here with the alpha would apply to each of the components within the square bracket. Beta, the exponent beta would apply to each of the components within the square bracket, and the gamma exponent here would apply to each of the components within the square brackets in here. So let's go ahead and do that. Now we're going to employ the properties of indices over here. Now we have M here, we have another M here, we have another M here. So we're going to add their exponents. We have L here, we have L here, and we have L here. So we're going to add the respective exponents of all the components within the square brackets. Now, from here, we're going to apply the principle of homogeneity of dimensions and compare the components on either side of the equation sign. And so applying the principle of homogeneity of dimensions on the left side of the equation, it means that which implies that alpha is equal to 1. It also means that which implies that and it means that which implies that beta is equal to 2. So from here we can do the inputting and find the value for gamma, because beta has been determined as 2, alpha has been determined as 1, so we can do the inputting to find the value of gamma. So it means that so 1, so here this implies 1. So gamma is 1, beta is 2, and alpha is also 1. So it implies that when we do the inputting, the formula is going to be so this is the formula for the force that the moving car experiences, which is due to the air resistance. So that is the formula. Thank you very much for watching, but keep watching.